Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.1, Problem 6. This is Section 11.1, Problem number 6. It says, consider the function x squared plus x minus 2 over x squared minus 1. And then you want to find the limit as x approaches these three different values. So in part A, you want to find the limit of x squared plus x minus 2 over x squared minus 1 as x approaches 0. So what I want to see is, can I actually put in a 0 and just see what would happen? And again, when you take the limit, you're not in reality putting in a 0, but you're putting in things super, super close to it. And I can. If I let x go to 0, it'll wind up being 2 over 1, really. So I can do that. So really, what's happening, the x squared on the top is going to get very close to 0 squared, plus x gets close to 0. There's a minus 2 at the end of that, so that's what happens to the top when I put in a 0 for x. And in the denominator, the x squared here becomes 0 squared, and I have the minus 1. And as I simplify that and just get rid of the zeros, I have minus 2 over minus 1. The minuses cancel, and I can just reduce it to 2. So as I start putting in input values or x values that are really close to 0, the output, or height on the graph if you graph it, gets very close to 2. So that's part A. B says, take the limit of the same function, x squared plus x minus 2 over x squared minus 1, as x approaches 1. Now this is a little bit more of a problem, because if you see in the denominator, it's going to wind up being 1 minus 1, which is 0. You cannot allow a 0 in the denominator. It's undefined. So I have to find some trick of putting in stuff very, very close to 1. So what I'm going to do is take the limit as x approaches 1 and try and factor this function somehow. Now I see the bottom first. It's a difference of squares. So I'm going to break it up into two parentheses. And I'm going to go x, x in each parenthesis. And one of them gets a plus 1 and the other gets a minus 1. That's how x squared minus 1 is factored. So you can FOIL this out and you can verify that you will get this. Now the problem comes from the x minus 1. The first parenthesis is okay. If I put in a 1 for x, 1 plus 1, that's 2. No problem. The second parenthesis, x minus 1, I get 1 minus 1. That's where I'm getting into trouble. So as I factor the top, I'm going to hope that it'll factor in such a way that one of the factors is x minus 1, hopefully. Let's see if I can do it. So I'll write that in first because I'm hoping to get that. And now, can I do x plus or minus something where it'll FOIL and give me what I have on the top? And it turns out that I can. So if I factor the top of my function, x squared plus x minus 2, it can be factored into x plus 2 times x minus 1. And if you do FOIL out x plus 2 times x minus 1, it will FOIL into what the top of the function was before, x squared plus x minus 2. Now that I have it factored, I have a function with an x minus 1 in the numerator and an x minus 1 in the denominator, which I can cancel. And then I can take the limit of what's left behind. So I'm going to take the limit as x approaches 1 of x plus 2 over x plus 1. And now I can just let x become 1 for both of these. Nothing bad will happen. So the top x plus 2 will become 1 plus 2. The denominator, x plus 1, will become 1 plus 1, which gives me 3 over 2. Now it doesn't really reduce. I could write it as a mixed number, as 1.5. It's the same thing, or you could also say 1.5, both good. So basically, you cannot just put a 1 into the function the way it was written originally in the problem. You can put in things really, really close to 1, 0.9999. And what happens is, as you put in values very close to 1 as input values, the output gets very, very close to 1.5. So you never actually get to 1.5, but you get as close to it as you need to. Like 1.49999, you can get an output like that. So on to part C. I want to take the limit of the same function, x squared plus x minus 2 over x squared plus 1, but this time as the input value approaches positive 2. Now, at a quick glance, if I put in a positive 2 for x, that should be fine. The denominator doesn't zero it out. It doesn't become undefined. So again, in reality, I'm not really putting in a 2 when I take the limit. I'm seeing what happens as I get very, very close to 2, like 1.9999. And by putting in a 2, it'll tell me what happens. So the numerator of my function, as I put in a 2 for x, the x squared becomes 2 squared. Oops. The plus x becomes plus 2. I have a minus 2. In the denominator, x squared minus 1 becomes 2 squared minus 1. And now I can just do the math for that. The 2 minus 2 at the end of the function, I can just cancel. So I have 2 squared, which is 4, over 2 squared minus 1. So 2 squared is 4. 4 minus 1 is 3. So I have 4/3, which could also be written as 1 1/3 if you like. It's the same thing. They're equivalent. So again, as I put in values as input values for x that are very close to 2, the output gets very close to 1 1/3.